Okay, we've got a velocity of an object given by this velocity function here, and we're asked to find the total number of feet traveled by the object in this time interval. And you actually have to be a little careful here because it says the total number of feet traveled. That could be both in the positive direction and the negative. So what you would want to do is take the definite integral from 0 to 3 of this function. The problem is that there's a portion where this velocity is negative and a portion where it's positive. When it hits 0 is, of course, when you plug 1 into here. 1 squared minus 1 is 0, and the whole thing becomes 0. So that's our breaking point, actually. Well, also when it hits 0, right, you plug 0 into there, you get 0, but you're not going anything below 0, so that doesn't really matter. When you're between 0 and 1, you can actually test this and see that v of t is less than 0. So that portion would, if you just took the whole integral from 0 to 3, would end up canceling with the portion, the positive portion, which is from 1 to 3. So we actually have to separate the interval between these two portions. We have to make sure that these two portions combine, they add up total. They don't, this will be negative, but we want to make sure it ends up being positive so that it can add up together. And we can find the actual total number of feet traveled. To do this, of course, we still have to take the integral of our function. So the integral of vt is going to be the integral of t times t squared minus 1 dt. And this is a u sub. So t squared minus 1, then du equals 2t dt. Of course, I can move the 2 over and get t dt. So, of course, this is my u. I have a t dt right there. So I get 1/2. I'm just going to move this 1/2 out in front. And I get u, oh, sorry, this is to the 1/3 here. Forgot about that. U to the 1/3 du. And doing the actual integral, we're going to get, this becomes added 1, so it's going to be 4/3, but if you take a derivative of that, you're going to break down to 4/3, so you need 3/4 in front. And there would be a constant integration, but I'm not going to worry about that because I'm going to take a definite integral over both of these. So it's just going to end up canceling. So we get 3/8 u to the 4/3. Of course, I need to go back to the original variable. That gives me t squared minus 1 to the 4/3. So now I can actually do my integration, or my definite integration using the fundamental theorem of calculus and find my answer. So this first interval, like I said before, we want to make this negative. You could, of course, instead of doing like this, t squared minus 1 to the 4/3 from 0 to 1, that would be negative because I know it's going to be a negative over this interval. So instead, what we could do to make it positive is just flip the bounds, 1 to 0. And then adding this up to 3/8 t squared minus 1 to the 4/3 from 1 to 3. This is going to be positive. Vt is positive in this portion, so I don't have to worry about flipping those bounds. So plugging in 0 into here, right? We're going to get 0 squared is 0, minus 1 is -1. Power of 4/3, well, the power of 4 is just -1, and the cube root of -1 is, or sorry, the cube root of positive 1 now is just 1. So it's just going to be 3/8. If you plug 1 into there, you get 1 squared minus 1 is 0. This whole thing becomes 0. So 3/8 comes from this portion. Then we get plus 3/8 times, plug 3 into there, 3 squared is 9, minus 1 is 8. So we get 8 to the 4/3. And then we plug 1 into there, you get 1 squared minus 1 is, well, that's just 0. So we just get 0 there. Okay, so now we have here, right, the cube root of 8 is 2. And we have 2 to the 4th power is 16. So now we have 16 times 3 is going to be 32/48. And that gives us 51/8 d.